For the second part of this section, we're going to talk about our rules of exponents. And there's really, there's no new rules in this section, it's just that we get to do arithmetic with different numbers. The rules of exponents we learned at the beginning of chapter 5 or so says if we multiply two things and they have the same base, then we add the exponents together. If we divide two things and they have the same base, then we subtract the exponents, top exponent minus bottom exponent. And if I get a negative number, then I need to drop that expression to the bottom and make the exponent positive. I don't ever want to leave any negative exponents in my final answer. I know anytime I have a power to a power, I'm going to multiply those exponents together. That's what we just did, only going in the reverse direction at the first part of section 8.2. And if I have products or quotients raised to a power, then every piece of that product or that quotient gets raised to that power. And in this case, power to a power means we multiply. Now these rules all hold true even when our exponents, actually I just want to get rid of that, even if our exponents are rational numbers. So multiplying like bases means I'm going to add the exponents together, but now when I add the two exponents together I get to find a common denominator. That common denominator is going to be 6, and when I take 3/6 and 2/6 I'm going to get 5/6. If I'm subtracting two numbers with the same base, then I'm going to subtract the exponents, 2/5 minus 1/10. Again, if I find a common denominator, 4/10 minus 1/10 is 3/10, x to the 3/10 power. If I have a power to a power, that means I'm going to multiply my exponents together. And if I multiply -4/9 times 12, I can reduce. I always want to leave my fractions in lowest terms. And so I will end up with x to the -16 thirds. Now, just like with our integer value exponents, I can't leave a negative number in my exponent. And so when I want to rewrite that expression and make it positive, just as we did before, I'm just going to drop it to the bottom and make the exponent positive. The fraction itself doesn't change other than its sign. This means 1 over x to the positive 16 thirds. Exponents to exponents mean I multiply. Products and quotients to powers means I multiply up here on top and I multiply on the bottom, and then I take care of things as I need to from there. 1/2 times 12 over 1 gives me 6. 12 over 2 is 6, and a positive times a negative is a negative. On the bottom, 3/4 of 12 is 9. Also positive times a negative is a negative. So in my final answer, the x to the 6th drops down to the bottom. Y to the -9 pops up to the top to become y to the +9. And we'll end up with y to the 9th over x to the 6th. All of the rules are the same as they were back in chapter 5, only instead of having nice numbers like 3s and 4s and 6s, we're now going to have fractions. So let's do an example, and I pulled this straight out of the textbook, out of the exercise set. This one kind of incorporates more than one rule, all three of them really, all in one problem. So if you want to go ahead and pause the video and try to work through this at your desk, our goal is to get an answer of p to some power, where this is a fraction in lowest terms. Single fraction. We need to combine all of these together into a single term. So pause the video, work through it, and then turn it back on to see how you did. On top, if we ignore the bottom for a bit, on the top we have a bunch of like bases, and so what we get to do is add the exponents together. I need to add 1/5, 7/10, and 1/2 together to get p to a single power. the common denominator for those fractions. I have 5, 10, and 2, so our common denominator is going to be 10. I'm adding 2 tenths, 7 tenths, and 5 tenths for a total of p to the 14 tenths power. Now, 14 tenths is not in lowest terms, but I'm going to hang out for a minute and wait because down the bottom I see I'm going to have some fifths and some things, so I want to see if I'm going to need to change that in a little bit. I may get to change it, I might get to leave it alone. On the bottom, power to a power means I multiply. 3 over 1 times 1 over 5 gives me 3 over 5, and positive times negative is a negative. Now, since I have fifths on the bottom, I need to either change this into tenths and add them together, or I can reduce my 14 over 10 and call it 7 over 5. But I'm going to need to be sure that those denominators are the same. And now I know that if I'm dividing two things with the same base, I'm going to subtract the top exponent minus the bottom exponent, which means I'm really going to get to add these two numbers together. And I'm going to get p to the 10/5 power. The 10 over 5 is just 2. So my answer to this whole big mess here is that I'm going to get p squared out of that. Homework. From section 8.2, I would like for you to do the following problems. Start at 15 and go to 90, counting by fives.